This is a more difficult version of a limiting reactants problem, and the reason it's more difficult is we're starting with something that typically students don't recognize, which is a solution of a certain concentration. So if you look in the problem, if you have 0.45 grams of copper, it's one of the reactants we're going to start with, and it's placed in 50 milliliters of 0.25 molar silver nitrate. There's the concentration that a lot of students don't recognize when they're doing the problem. First question is, what is a limiting reactant? And the second question is, how many grams of silver nitrate are produced? So we really can't answer the first question without doing a lot of work for the second question, so we're actually going to do just about all the work for both questions before we can answer both of them. Now that I've made a little more room for myself, I'm going to start out with my 0.45 grams of copper in my first T table. So 0.45 grams of copper. I'm going to convert this to moles using my molar mass. Molar mass of copper is 63.55 grams for every 1 mole of copper. I'm going to go to silver using my mole ratio. There's 1 mole of copper for every 2 moles of silver. 1 mole of copper goes on the bottom. 2 moles of silver on top. And I'm finally going to go to grams of silver using my molar mass of silver. 1 mole of silver is equal to 107.87 grams of silver. After calculating, I get 1.53 grams of silver. So what this tells me is with my 0.45 grams of copper right here, I can produce 1.53 grams of silver. The only thing I have to do now is I have to figure out how many grams of silver I can produce from my 50 milliliters of 0.25 molar silver nitrate. So my next T table is going to start off with 50 milliliters of silver nitrate, AgNO3. Now, many of you probably need to know what that big M I keep on referring to as molar stands for. The big M, molar, refers to moles per liter. So I have 0.25 moles for every 1 liter. Notice that I'm starting with milliliters though. So my first step is to convert my milliliters to liters. I know that 1,000 milliliters is equivalent to 1 liter of silver nitrate. So now I can plug in my 0.25 molar because it's 0.25 moles for every 1 liter of silver nitrate. Notice how my liters cancel out quite nicely now. My next step is to go from moles of silver nitrate to moles of silver. So I have 2 moles of silver nitrate for 2 moles of silver, so it's a 2-to-2 ratio. My moles of silver nitrate go on bottom. I have to make some more room for myself here. And my 2 moles of silver go on top. So I'm going to make some more room for myself here, shrink this down, push it over. Next step, go from moles of silver to grams of silver using that same final step that I used in my first T table. So for every 1 mole of silver, I have 107.87 grams of silver. I'll make a little more room for myself again for my calculation. My final answer here is 1.35 grams of silver. So what this tells me is that with my 50 milliliters of silver nitrate, I can produce 1.35 grams of silver. Now, back to the first question. What is the limiting reactant? So the limiting reactant here would be the one reactant that produces less silver, which would be the 50 milliliters of silver nitrate. So this is equal to your limiting reactant. Now, by doing the work to find the limiting reactant, I actually found my answer to the second question. How many grams of silver can be produced? Well, we're going to be limited to producing 1.35 grams of silver.